In this demo, we're going to explore a character-based language model, and we will generate some text in two different genres using a recurrent neural network. A language model is a mathematical model that assigns probabilities to strings in a language. Equivalently, we can understand it as a model that predicts the next word after listening to the previous words in a piece of text. In this particular case, the model we train is going to predict the next character, next letter, after seeing the first n-1 letters of a given piece of text. This demo was inspired by the excellent blog post by Andrea Karpathy, The Unreasonable Effectiveness of Recurrent Neural Networks, in which he goes on and describes what recurrent neural networks are and what kinds of text you can generate with character level language models. So here's a depiction of what a character level language model looks like. So here are the input characters. At top we see the output characters, and the model works by taking, for example, the input character H and predicting the next letter will be E, and then it takes E as its next input and predicts that the next character will be L, etc., etc. This is how it generates the word hello, for example. So we're going to take this model and train two different generators from it. The first code box loads the data and the models, and the first model we're going to look at is trained on the complete works of William Shakespeare. So here is some sample data from this. This is a book which has about 5 million characters that contains everything Shakespeare wrote, all the plays and sonnets, as you can see. So you can keep hitting Control Enter in this box to sample different parts of the book. And after feeding this book character by character into a recurrent language model, recurrent neural network model, we can actually have it now generate similar text. So here is an example. Let's do it again. Okay, this looks a bit better. A couple of things that I want to mention here is basically, even though this model has no understanding of English, it only basically learned to predict the next letter given the previous letters. It's actually learned some amazing things. For example, it starts every line with a capital letter. It indents things properly. It puts some character names in the beginning of certain lines, make it look like a play. And most of the words look like English words, and some of the sentences even almost make sense. So this is the Shakespeare example. Now we can take almost exactly the same model and use it to generate something very, very different. This time I'm going to feed some Julia code into this model. So here's some examples from the Julia standard library. This is the real Julia code written by programmers. As you can see, there's different commands, indentation, there is comments in the code that basically have some English stuff, and there's a similar amount of Julia in the standard Julia library as there's text in Shakespeare, so we can train a similar model using this. And here's the resulting generation from this model. So by hitting Control Enter, I can generate random Julia code, or random text that looks like Julia code. So a couple amazing things is it actually has comments, and inside the comments it says things like dispatch, line methods, for loop with the name must be integer, etc. So it almost sounds like English. It has understood certain constructs require, for example, an end keyword at the end. So it starts defining a new struct, ends with an end. It indents a function properly. If it actually has an if-else and clause here. It uses other Julia-specific conventions like types, etc. And most of the function and variable names actually make sense. For example, recursive unit range. So, as I mentioned before, you can have fun with this by clicking Control Enter and generate random bits of Shakespeare.